Today's messing around is assisted by Juice of the Oats Oatmeal Stout from Oxus Brewing Company in Winnipeg. They call it an easy drinking dark ale with the aroma of coffee and chocolate, smooth body, and of course oats in the mash, which is what you'd expect from an oatmeal stout. And it's got a pretty good head on it as well. So today I am taking a look at another thrift store find. This one cost me an entire $5 from the Salvation Army minus my 55 plus discount. Woohoo! It is Auto Trends branded, AC powered, and it is a multi-port USB charger that claims a total of 6.8 amps out of the 4 outputs. And that, if it does what it claims to do, could solve some problems for me. As you see off to the side of my workbench, I have a whole bunch of USB chargers plugged in, and then another wall wart powering that USB power bar that I use for various things. One of them's powering that sign over there. One of them's powering the camera that's sometimes rotating up above the workbench. And often I have other things if I'm using something with USB on the workbench, and on and on and on. But as you saw, that those two AC power bars off to the side there are just choked up with wall warts. So if I can replace 4 of them with this thing and still not exceed the power loading of this, I think that will be a win, if it works. A few more statistics down on the bottom. It can take anywhere from 100 up to 240 volts, 50-60 hertz, so global universal, and puts out 5 volts at 6.8 amps, 34 watts total. So let's get some power onto this thing and see if it does anything at all. Well, there's a blue light comes on down underneath it, so I guess it's powered itself on. That's something. And to power it on, I actually had to unplug something, so I'm running without this one light off to the side of my workbench, which is a little annoying. So let's see if it's got power on its outputs. Yeah, there's 5 volts on that one, and at the same time 5 volts on that one, so that's cool. Let's plug something into there. This is a 1 amp, 2 amp switchable load. So we'll start with, oh, there's 2 amps right there, or the 2 amp setting. It actually says it's drawing 1.69 amps, and it's pulled the output down to 4.83 volts. Although it hasn't impacted the other outputs, that one is still at 5 volts, so that's good. Now then, I don't want to put all 6.8 amps out one output, because as you can see over here, it does cause a bit of a sag. Plus, in my research, I found that the standard USB-A connector is only really rated at 2 amps maximum. So I do want to spread it out amongst the 4 outputs a little bit. And in order to spread the load out, I have soldered up some resistors onto some USB cables, just various power resistors that I had kicking around. These are the ones that I bought to expand my variable load, which is not working right now, so I'm not going to use that tonight. But I have a few other options. So in my testing, just with a normal wall wart before I did that, this one draws 1.5 amps. This one here with the same resistors draws 2.25, and I put the difference down to the lightness of the cable that's feeding them. This little conglomeration draws another 0.5 amp. So let's start plugging stuff in. Let's plug the 1.5 amp one into this guy, and it draws that power down a little bit, but it is also doing 1.45 amps according to that. So that's close to 3 amps, 2.75 amps so far. But with these guys plugged, or with the meters plugged in, unfortunately that messes with me a little bit because I don't have room. That takes up too much physical room. So I'll move that 1.5 amp over a little bit, and can I plug that guy back in? No. Can I plug him in over there? No. So now we have 1.5, 2.25, so 3.75, and another almost 2. That's a total of 6.15 amps by my math, which is close but not exactly right to what that 6.8 is. So I think what I will do is also bring in this load, which again is not ideal because of the way it works. I have to keep resetting it for each different amount, but I'll take that smallest half amp one out of there and connect it in. I've got it wired up through some very heavy wire, much heavier than you would normally use for USB, so I think that's okay. And we'll see what happens. So now with this guy in here and this half amp load not in here, we have a total of 5.65 amps with this off from that and that and that. And yeah, those are starting to get pretty toasty. So by my math, I need another 1.15 amps from this guy to get up to the 6.8 that that thing claims to have. I've got this guy set for 1.15 amps. Turn it on. And it is drawing it. It's drawing that voltage down a little bit, but it hasn't drawn that one down any at all, which is nice. So I'm just going to step through and see what it takes to crash the thing. There is 1.5 amps being drawn there, and it's still handling it. It hasn't done anything bad to the other outputs. Yeah, that one's still 4.5 volts through that fairly skinny little wire. So I've decided to pull this little resistor cluster out of this so that we're not getting the voltage drop through that lead, and I can just measure the voltage directly on here, which is 4.75 volts. So that's not going to be a crash yet. So let us turn this guy up to, say, 2 amps, which will put us well above our 6.8 that this thing claims. Let's see what happens. Still taking it. That one's dropped a little bit. 4.6. Yeah, so it's taking it. I'm not going to push it too much further. I'm about 0.5 amp above where this thing claims to be able to go, so I think I am good with that. Let's shut some of this off here, let it cool down, and then take this thing apart and see what's inside it that's providing all that juicy current. So far, I am quite pleased with this thing, and it didn't get noticeably warm except for right by the connectors where I had all that heat coming off that resistor. By the way, my hot resistors are sitting on the concrete floor behind me where they can't cause any problems. So let's get into this thing. By the way, yeah, let's see, we've got to get underneath those feet, I'm guessing, to try and find some screw holes. No. Okay, plan B. How would it be put together? Clips, maybe? Yep. Okay, you just have to find where... Oh, yeah. So those things do come out. I assume those are for holding phones in here while you're charging them. That would be my guess. It would make sense, wouldn't it? Sure. I'm just going to dig around in here, hoping that there's no charged up capacitors, and try and figure out how to get this thing to reveal its secrets. Running out of spudgers here, but maybe... Oh, really? Is that a screw under there? Yes, there's a screw under the corners underneath that. Okay, well, let's pull all of these spudgers out and I guess just peel up the sticky rubbery surface stuff in the corners. You see, I'm trying not to destroy this because after discovering that it actually lives up to its claims for amperage, I do actually want to use it for the reasons mentioned at the beginning of the video, to clean up my power bar so that I actually have room to plug more things in. Woohoo! Okay, now will it come up? Is there more hidden screws under here somewhere? Do I have to pull that rubber all the way off? I don't see any more screws. Because there are probably clips down in there too somewhere. Okay, I will carry on and see what happens next. Ah, damn it, there's one more screw in the front. Fine, be like that. Now will it come open? And another one there. Man. Alright, with that out, surely that's all of it. Oh, that was a bear. So there was 6 screws, 4 in the corner, 1 inset there, and then 1 kind of centered in the front. Okay, but after all that ordeal, we are in. And what do we have here? We have the live and neutral coming in there. We have a fuse, which is labeled 3.15 amps, 250 volts. Then we have a Class X capacitor, an inductor, which looks like a common mode choke kind of thing, another Class X capacitor, another inductor, which again looks very much like a common mode choke, which is pretty wild level of protection in the beginning. I have good hopes for this thing being quality. Anyway, after that choke, we have a bridge rectifier, and we have 2 big beefy capacitors, 22 microfarad 400 volt and 33 microfarad 400 volt. And neither of them look domed. They look fairly solid. That's nice. I'm not going to do a full schematic of this, but I'm going to guess that there's stuff hiding under the board, because I see a switching transistor there on this heat sink. I see 1 diode there, a small capacitor. That looks like an optocoupler. That is an obvious transformer. Looks like it's got 2 sets of windings there, and then 1 set of secondary windings over here. And then on the secondary side, we have a couple of large power devices, a couple of 6.3 volt capacitors, a Class Y capacitor, which is probably jumping over the gap back to this side again, as it should. 500 microfarad 6.3 volt capacitor, and then just a series of LEDs, 4 LEDs down there, which would be sitting underneath these guys, edge lighting them out the top, like that. And nothing else to see on the top, 4 connectors. So I guess we should pull those 4 screws and see what's underneath. So far it has everything you want in a power supply. And I am impressed by the amount of filtering and protection that there is on the AC primary side there. That's nice to see. Okay, so what happens when we lift that out? The screws go flying. Oh yeah, there's a lot going on in the back of this board. Actually, not as much as I expected. There's a couple of chips, resistors, diodes. There's 1 more small 6-pin chip over there. A few fairly beefy traces out here near the outputs. And yeah, that's kind of neat. A few jumper wires. Okay. So here's the back of those power devices, those 2 power devices that are on the big heat sink. So this heavy track here goes to that pin, that pin, that pin, and that pin of the 4 connectors. So then the other side jumps over there from these devices through this heavy track, goes through 2 resistors, 0.47 ohms, labeled RCS1, RCS2. Those are current sense resistors, obviously, and they go to both the shell of the connector and that pin. So that is the negative side, which means this one up here is the positive side. So it's current sensing on the negative side. And that heavy track carries on down here, does the same thing there and there and there. And then it looks like the 4 connectors have a couple of different things going on. These 2 connectors, the data pins, connect over to this U5 chip, which, as close as I look at it, I cannot find any markings on it. And these 2 down here have a set of 4 resistors between the data pins and ground and 5 volts on each of them. So those are using 2 different methods, I'm assuming, to indicate to the device being charged how much voltage or how much current each of these can supply, which is kind of clever, and I'm sure if I had a manual for this thing, it would explain all that. Anyway, the other stuff that's going on this board, I'm disappointed that none of these chips have numbers on them that I can see even up close with my 10 times magnifying glass, so I'm just going to have to make some vaguely educated guesses. This little 6-pin here, it does have a connection to this device here, which is the switching transistor, switching MOSFET, probably on the high voltage primary side. I can see a trace going from that chip to this guy, and I can see a trace going from this to the transformer. So that's what's happening on there. That's just standard switch mode power supply stuff. And there's also a trace going to that little 6-pin chip from the optocoupler, and the optocoupler will be monitoring the voltage on the secondary side. So this chip here and its little cluster of resistors and a diode, which again I can't identify it, but it just says D there. Those are connected to these power transistors here, these two drive transistors, which are providing the high current to the outputs. So that will be controlling those two transistors, monitoring the voltage and ordering them around appropriately. And this guy has traces that can find their way back to those current sensing resistors. So I'm going to guess that that's what he is doing, is just monitoring the overall current. And if it gets way too out of hand, it'll order this guy over here to shut down. Without readable part numbers on there, it's really difficult to make more than just educated guesses based on seeing dozens and dozens of other power supplies. But all in all, I'm pretty pleased with what I'm seeing. There is gaps in the circuit board where you would expect them to be. The main transformer is sitting over this blank piece of the circuit board. That slit is underneath the optocoupler. It's fused. As I said, it has all this protection stuff in the beginning on the AC side before it even starts chopping it up. A couple of good-sized capacitors on the 400-ish volt AC. So, yeah, I am pleased with what I see here, and I am not going to be the least bit concerned about using this on my workbench going forward. The only challenge I have is to put it all back together, and I think now that I know where the screws go, that won't be too hard, except that I can't get my meat hooks in there, so I have to do this the delicate way, but I shall persevere. There, all back together, and yeah, you can definitely tell I was in there, but doesn't matter. It works. I'm pleased with it. I'm going to figure out a place to mount it off to the side of my workbench. I don't think I'm going to put these plastic things back in there. Those don't really matter anymore, but there it is. I am pleased with what I saw. A little disappointed that I couldn't read the components in there and get more information about it, but it's a fairly standard circuit, fairly beefy, fairly heavy duty, 6.8 amp total USB charger. That is going to come in handy to get rid of that mess that's off the side of my workbench. Well, thanks for watching, everybody. Appreciate that as always. Questions and comments down below. I will talk to you later.